So when we see mutations, most of the time, if not the majority of the time, mutations don't produce anything that's like an improvement, right?
They don't make an effect that manifests itself in the organism's body.
So where does microevolution fall in that category?
There's a lot of great research that we're doing and that a bunch of labs around the world are doing, trying to figure out how trait differences, trait variations happen. So I'll just give you one example for the sake of time. Darwin's finches, the famous finches on the Galapagos, are supposed to be an example of evolution and mutations, shifting the finch beaks from short to skinny. And so they're supposed to be evolving, it's evolution in action, that's what we read in the headlines. But a group of geneticists discovered that there's an algorithm. It's an epigenetic algorithm. So, the short-beaked finches have the same exact genes as the long-beaked finches, and there's no mutations happening to make the shift at all. Instead, there's a programmed algorithm that's epigenetic. It approximates precisely the regular mathematical formula for a cone, for construction of a cone shape. Beaks are essentially cone-shaped, and they found the epigenetic markers in the developing finch beaks. The trait adjustments are happening by design. It's looking more and more like that, by internal programming. So we have a whole theory about that called continuous environmental tracking that you'd be really interested in. Organisms are tracking their environments, and then they're collecting those data, and then they're deploying trait variations in the next generation or in 6 generations down the line that are going to help that offspring thrive, not just survive, but thrive in an ever-changing world according to design.
But it's not a mutation because it was already there, and it's just like being triggered?
Yes.
Okay.
It's already there. So geneticists call it standing genetic variation, and that means it was already standing there from creation.